Hello everyone. The topic of today's lecture is Construction Engineering Economics Internal Rate of Return IRR. The first part of IRR will mainly cover the following two aspects. Overview of internal rate of return. Several special cases of internal rate of return. Let's start with an example. If you deposit 15 million yuan in a bank with compound interest, and then withdraw 9 million yuan, 8 million yuan, and 5 million yuan at the end of each of the following 3 years respectively, with the bank deposit balance being 0 at the end of the third year, what is the interest rate of the bank deposit required to achieve this purpose? This is represented by a cash flow diagram. At the end of the first year, minus 1500 multiplied by left parenthesis 1 plus right parenthesis plus 900. At the end of the second year, left square bracket minus 1500 multiplied by left parenthesis 1 plus I right parenthesis plus 900 right square bracket multiplied by left parenthesis 1 plus right parenthesis plus 800. At the end of the third year, left curly brace left square bracket minus 1500 multiplied by left parenthesis 1 plus right parenthesis plus 900 right square bracket multiplied by left parenthesis 1 right parenthesis plus 800 right curly brace. Since the deposit balance is 0 at the end of the third year, the following equation holds. Multiplied by left parenthesis 1 plus right parenthesis plus 500. Minus 1500 multiplied by left parenthesis 1 plus right parenthesis multiplied by 3 plus 900 multiplied by left parenthesis 1 plus right parenthesis multiplied by 2 plus 800 multiplied by left parenthesis 1 plus right parenthesis plus 500 equals 0. Left parenthesis net future value right parenthesis. If we divide both sides of the above equation by left parenthesis 1 plus right parenthesis raised to the power of 2, we obtain the net present value NPV of the scheme, i.e., NPV equals minus 1500 plus 900 multiplied by left parenthesis 1 plus right parenthesis raised to the power of minus 1. Plus 800 multiplied by left parenthesis 1 plus right parenthesis raised to the power of minus 2 plus 500 multiplied by left parenthesis 1 plus right parenthesis raised to the power of minus 3 equals 0. Therefore, to achieve the above objective, we need to find the interest rate at which NPV equals 0. We previously discussed the relationship between NPV and I. And we observed this pattern. When the net cash flow of a scheme remains constant, NPV decreases as I increases. When I equals I with an asterisk, NPV equals 0. When I is greater than I with an asterisk, NPV is less than 0. When I is less than I with an asterisk, NPV is greater than 0. We refer to I with an asterisk as the internal rate of return IRR. The higher the I asterisk, the fewer schemes are available for selection. In this section, we will introduce the internal rate of return to you. Definition of internal rate of return IRR. The internal rate of return refers to the discount rate or interest rate at which the net present value NPV of the cash flows of a project equals 0 over its life cycle. It is denoted as IRR. Formula for calculating internal rate of return IRR. Let's examine the expression for internal rate of return IRR. NPV equals the sum of left parenthesis CI minus C0 right parenthesis sub t multiplied by left parenthesis 1 plus IRR right parenthesis raised to the power of minus t. For each time period t from 0 to n equals 0. It involves multiplying the annual net cash flows by the present value factor for a single payment. In other words, all net cash flows within the life cycle are discounted back to the present time 0, and the discount rate is found where the net present value NPV equals 0. Discriminating criteria. First, single scheme evaluation. First, when IRR is greater than and equals I sub c, it indicates that the project's rate of return has reached or exceeded the benchmark level, making the project feasible. When IRR is less than I sub c, it suggests that the project is not feasible. R. Comparison between multiple schemes. The criterion of maximizing the IRR does not always hold true. Fourth, special cases of internal rate of return IRR. First, situations where the internal rate of return IRR does not exist. There are situations where the internal rate of return IRR does not exist. In the first case, when there are only cash inflows, as depicted in this graph with only incoming cash flows, the net present value NPV cannot be zero, and thus the IRR does not exist. In the second case, when there are only cash outflows, the NPV also cannot be zero, and therefore the IRR does not exist. In the third case, when the algebraic sum of cash flows is less than zero, the NPV will not equal zero either, and hence the IRR does not exist in these three scenarios. Second, non-investment situations. A non-investment situation is a relatively special case, contrary to conventional investment projects. In this scenario, funds are first obtained from the project, and then related expenses of the project are repaid. Internal rate of return IRR Part 2. This section will mainly cover the following four aspects: the economic meaning of IRR, solution for IRR, applications of IRR, characteristics of IRR. The economic meaning of IRR. Here is a case we previously analyzed. You deposit 15 million yuan with compound interest in a bank, and withdraw 9 million yuan, 8 million yuan, and 5 million yuan at the end of each of the following 3 years, respectively. At the end of the third year, the balance in the deposit account is zero. What interest rate must the bank offer to achieve this outcome? At the end of the first year, minus 1500 multiplied by left parenthesis 1 plus right parenthesis plus 900. At the end of the second year, left square bracket minus 1500 multiplied by left parenthesis 1 plus right parenthesis plus 900 right square bracket multiplied by left parenthesis 1 plus right parenthesis plus 800. At the end of the third year, left curly brace left square bracket minus 1500 multiplied by left parenthesis 1 plus right parenthesis plus 900 right square bracket multiplied by left parenthesis 1 plus right parenthesis plus 800 right curly brace multiplied by left parenthesis 1 right parenthesis plus 500. Since the deposit balance is zero at the end of the third year, we have the following equation: 1500 1 plus 3 plus 900 1 plus 2 plus 800 1 plus 500 equals 0 net future value. If we divide both sides of the above equation by left parenthesis 1 plus right parenthesis raised to the power of 2, we obtain the net present value NPV of this scenario. NPV equals minus 1500 plus 900 left parenthesis 1 plus right parenthesis raised to the power of minus 1. Plus 800 multiplied by left parenthesis 1 plus right parenthesis raised to the power of minus 2 plus right parenthesis raised to the power of minus 3 equals 0. Therefore, to achieve the above goal, we need to find the interest rate at which NPV equals 0. From the input perspective, IRR reflects the maximum interest rate that a project investment loan can bear. From the output perspective, IRR represents the level of return that a project can achieve. We can see the relationship graph between NPV and the interest rate I. NPV decreases as I increases. When I equals I with an asterisk, NPV equals 0. When I is greater than I with an asterisk, NPV is less than 0. First I sub 1 is less than I sub 2, and the difference between I sub 1 and I sub 2 is less than 2%. Solution for internal rate of return IRR trial and error method. E. Initial estimation. Choose an initial value for calculation. R. Trial calculation. Second, NPV f parentheses right parentheses is greater than 0, NPV I sub 2 is less than 0. Is generally not more than 2% with a maximum of 5%. Let's set I sub 1 equals I sub c equals 10% and calculate the value of NPV1. Third, if don't meet above two conditions, re-estimate until they are satisfied. Calculation using linear interpolation. Similar triangle principle. Select two discount rates, I1 and I2, with the difference between I1 and I2 generally not exceeding 2%, and at most not exceeding 5%. Ensure that the calculated net present values for these rates are such that one is greater than 0, and the other is less than 0. Finally, apply the formula. Application of the internal rate of return IRR method. Let's look at a case study. The net cash flow of a certain engineering project is shown in the table, with a benchmark return rate of 10%. Try to analyze whether the project plan is feasible using the IRR method. Based on the cash flow statement, draw cash flow diagram. At the beginning of the first year, there is an inflow of 2,600 units of cash, so the arrow points downward. At the beginning of the second year, there is an inflow of 300 units of cash, so the arrow points upward. Then, for the next 4 years, there are inflows of 500 units of cash each year, so the arrows for these years also point upward. At the end of the 6th year, there is an inflow of 1,800 units of cash, so the arrow for this period also points upward. Solution. Step 1. Estimate an appropriate trial rate of return. Let's set I sub 1 equals I sub c equals 10% and calculate the value of NPV1. NPV1 equals minus 2,600 plus 300 multiplied by left parenthesis p over f, 10%. 1 right parenthesis, plus 500 multiplied by left parenthesis p over a, 10%, 4 right parenthesis multiplied by left parenthesis p over f. 10%, 1 right parenthesis, plus 1800 multiplied by left parenthesis p over f, 10%, 6 right parenthesis, equals minus 2,600 plus 300 multiplied by 0.9091 plus 500 multiplied by 3.1699 multiplied by 0.9091 plus 1800 multiplied by 0.5645 equals 1.29708 million yuan. Step 2. Set I sub 2 equals 12% and calculate the value of NPV2. NPV2 equals minus 2,600 plus 300 multiplied by left parenthesis p over f, 12%. 1 right parenthesis, plus 500 multiplied by left parenthesis p over a, 12%, 4 right parenthesis multiplied by left parenthesis p over f, 12%, 1 right parenthesis, plus 1800 multiplied by left parenthesis p over f, 12%, 6 right parenthesis, equals minus 2,600 plus 300 multiplied by 0.8929 plus 500 multiplied by 3.0373 multiplied by 0.8929 plus 1800 multiplied by 0.5066 equals minus 0.64247 million yuan. Step 3. Use linear interpolation to calculate the IRR. IRR equals 10% plus 129.708 multiplied by 2% divided by 129.708 plus 64.247 equals 11.34%. Since IRR equals 11.34%, which is greater than I sub C, which equals 10%, this project plan is feasible. Characteristics of internal rate of return IRR. First, advantages. Reflects the efficiency of investment use. With a clear and definite concept. Does not require a predetermined benchmark return rate, as it can be calculated based solely on the project's own cash flow. Second, disadvantages. May not provide a unique and definite value. In all situations, generally cannot be directly used for comparison and selection among multiple project plans. For watching this video, thank you all.